Namaste to all of you. In today's video lecture, we would like to discuss about the topic alkalinity, determination of water. So, alkalinity can be determined in a given water sample by a volumetric analysis. But before we proceed, I have a appeal to all of you. Please subscribe my channel, press the bell icon, do comments on the comment section, and like and share this video. So before we proceed, we would like to discuss about the alkalinity. What is alkalinity? So alkalinity is a ability of water to neutralize free acids. It means that alkalinity means presence of certain negative species, for example OH negative ion, bicarbonate negative ion, carbonate negative ion in water sample, and such kind of alkaline water is able to neutralize a acid content, then this tendency of water is called as alkalinity. How can you determine alkalinity in laboratory? The answer is by volumetric analysis. Volumetric analysis. To perform volumetric analysis, we have to go for a titration method. Titration. And here, for the determination of this water alkalinity, the titration is called as neutralization titration. Neutralization titration. This titration is referred as neutralization titration because the endpoint detection or coming of endpoint is due to the acid base reaction, a famous acid base reaction in which salt is formed with some amount of water. So whenever acid and base are mixed, the reaction is very instantaneous, and the and the result is salt formation and the production of water. So when this reaction completes in a conical flask, the change of indicator is shown. So the change of indicator implies the coming of endpoint, and this endpoint comes due to the acid base neutralization reaction. Hence this particular titration is referred as neutralization titration. Now the chemicals required. Now the chemicals required for this practical. So number one is water sample, WS. It may be any type of water sample which is alkaline in nature. Number two is acid solution. Acid solution means whether it is HCl solution or H2SO4 solution. The normality of these acid solutions is known to us. Normality is already known. And the third requirement is indicators. So we use two type of indicator for this particular practical. The first one is phenolphthalein. Phenolphthalein is a peculiar indicator which shows a wide and sharp color range. It is pink in alkaline medium, which gets turned into colorless appearance when the acid medium comes. The second one is methyl orange indicator. Methyl orange indicator. It shows yellow color in alkaline medium and changes into pink color when acidic medium comes, but this pink gets mixed into this yellow color. The overall appearance is orange color. Now the procedure of the method. How can we perform this titration in a laboratory? So first of all, we take 10 ml of water sample. Then we add 1 drop of phenolphthalein indicator. So we get here a pink color. When pink color appears in a conical flask, put this conical flask under the nozzle of burette in which a certain acid solution is filled. Suppose sulfuric acid solution is filled, whose normality N is known to us. When we add drop by drop, sulfuric acid solution in this 10 ml water sample which has been taken in conical flask, the pink color finally disappears and the colorless condition comes. Once we have a colorless condition, now we add in the same conical flask the 2 drops of methyl orange indicator MO. So we get here yellow color. Now put once again the conical flask in which yellow color has been appeared under the nozzle of burette with the same burette. We have to use the same burette in which known normality, the sulfuric acid of known normality is filled. Add certain amount of the sulfuric acid solution in the yellow colored conical flask in which 10 ml of water sample has been taken, titrate it, shake it, titrate it, and finally you get a pink color which gets mixed into the yellow color. So final appearance is orange. So in this whole procedure, you are watching here that the particularly two times the endpoint is coming, or two times the original color of indicators changes. First, the pink color due to phenolphthalein changes into colorless condition. It is called as first endpoint or P endpoint. And the second time, the yellow color which has been come due to the addition of methyl orange converts into pink color. This is called as second endpoint or M endpoint. So this is the first step. Now go for a second step. In the second step, we follow the same procedure as followed in the first step. So you have to confirm the both the readings coming both the readings come in the first both the readings came in the first procedure, first step. So you have to get, suppose we have P is 1.5 and M is 5.0 in the first titration. So now in the second titration, you have to confirm these two readings. In the second procedure, if you have 1.5 phenolphthalein endpoint once again and 5 methyl orange endpoint once again, it is the meaning that you have confirmed the two readings. So these readings now can be considered in our final calculation. Now calculations. So we use a formula for calculating the alkalinity content of water sample. Formula is N1V1 is equals to N2V2. Here N1V1 stands for water sample and N2V2 stands for the particular acid solution. The N means normality, V means volume. N1V1 normality and volume for water sample, N2V2 normality and volume for acid solution. So you calculate N1 is equals to N2V2 divided by V1. When N1 comes, the alkalinity is equals to N1, that means normality, multiplied by 50. So you will get here the content, alkalinity content in gram per liter, and if you multiplied 1000 here, you will get the answer in milligram per liter or parts per million. There is a one direct approach here. This N1 is actually formula strength is equals to normality multiplied by equivalent weight, and to find normality we may write here strength divided by equivalent weight is equals to normality. You may write here N1 is equals to strength, that means alkalinity, divided by equivalent weight, which is 50, because alkalinity is measured in terms of calcium carbonate equivalent. So now we may write here in the place of this N1, alkalinity divided by 50 is equals to N2 into V2 divided by V1, or alkalinity is equals to 50 into N2 into V2 divided by V1, or alkalinity is equals to equivalent weight E into normality N into volume V divided by V1. So you may directly use this formula, which is more simpler than this step, which is less time taking as compared to this whole step. So here E is the equivalent weight of calcium carbonate, that means 50. N is the normality of acid solution, V is the volume of acid solution, and V1 is the sample solution volume of water sample. Now this is the way to calculate the particular alkalinity content. What is the meaning of this P and M? So P and M have the relationship with each other, and 5 cases are actually originated, 5 cases are arised. Case number 1, when P is equals to M. Case number 2, P is equals to half M. Case number 3, P is equals to 0, but M is equals to certain volume V, and P is greater than half M, and the 5th case is P is lesser than half. All these cases have been discussed in my another video. So to gather the knowledge about these all 5 cases and their related chemistry, please go for my another video. This is the way how we can calculate the alkalinity content of a water sample in the laboratory. I have discussed about the determination of alkalinity of water, what is alkalinity, definition of alkalinity, how can we determine the alkalinity in the laboratory, why the determination method is called as neutralization and titration method, what is the reason behind it, the chemicals required for the procedure, what is the whole procedure, and what are the calculations. Thank you very much.